Hi everyone, thank you for the opportunity to present to you. I'm Arijit Sengupta, the founder and CEO of Aible. Before this, I started a company called Beyond Core, which was acquired by Salesforce. And of course, it's part of the broader Tableau and analytics offerings from Salesforce now. I also helped co-create and co-teach a course on AI and market-facing functions at the Harvard Business School. The team had done more than 2,000 real-world AI ML projects before we started Able. So we were able to learn from all the mistakes we had made over decades of creating AI products to make sure we were actually focused on delivering value. More on that later. We have, of course, partnered with most of the leading companies in this space, including Intel, Salesforce, and others. Gartner rated us number one for the AutoML use case in their critical capabilities for cloud AI developer services. We believe the reason we were rated so highly actually is because of our obsessive focus on delivering the business need for business users. And that's what Forrester has talked about in this quote. Now, fundamentally, how do you know that we can create value? Well, because we give a satisfaction guarantee on it. And that's what 451 is talking about, that nobody else in the space actually has the ability to give a 30-day guarantee that if they don't see value in 30 days, they don't have to pay for the project. These are some of the reviews we have gotten on the Gartner Peer Insights website. Please go take a look at them. This is from the healthcare industry, one of the largest companies in the space, talking about how they got the model stood up with their business partners in weeks, not months. And we are working with Intel to do these series of case studies, these customer spotlights, to show how companies across industries are getting to value in less than 30 days. This is a sales opportunity prioritization use case in a Fortune 500 company. We got that done in 20 days. Multinational CPG looking at salesperson onboarding and first order optimization done in 17 days. Customer spotlight on perishable goods overstock. The project got done in 27 days. Late shipment prediction and expedite optimization again got it done in 14 days. So significant results to the tune of $10 million of additional revenue, for example, in less than 30 days. And please go take a look at the rest of the case studies, some of which are already in and some are coming soon. Now, how is it that we are going in and creating value so quickly? Well, first think about where you are on your AI journey, and we have targeted solutions for every step of this journey. You might be the world of overwhelming data going to valuable data. This is where you know you have a lot of value in your data, but you don't know which part of your data is garbage and which is gold. And typically you throw consultants and expert analysts to manually go analyze that data to figure out whether there is value. Some might even be doing a data warehousing project, trying to first organize the data before they can figure out whether it has value. That doesn't make much sense. Rather than putting all of your effort on data, whether or not it's garbage or gold, what Aible Sense helps you do is completely automatically, without any effort, figure out, is your data ready? Can this be used for analyzing data and just drawing dashboards, for example? Can it be used for training in AI? Should it be put into a data warehouse? So think of Sense as your first cut to figure out, does the data even have value before we do anything else with it? It's completely automated and runs on the least expensive IT resources possible, which is serverless plus file storage. This is Aible Sense. Here you can access almost any data source, and the data that you are accessing is evaluated in your own cloud account. In AWS or Azure, the data never hits Aible's servers. As soon as you point Aible at any data source, it automatically does various data quality checks. It'll do these kind of outlier checks, missing values, are there any duplicate headers and things of that nature. Once you choose the outcome, which in this case is a loan approved is the outcome for this data set, it'll start evaluating it automatically to figure out, is this data set good if I want to predict loan approved or if I want to draw graphs where loan approved is on the vertical axis. This takes a few minutes. So I'm going to go to this process that I've done before. What this is telling me is this data set has a data readiness score of 5.1, and Aible has found 33 useful variables and variable combinations in this data set. For example, it's telling me gender is an important one. Whoa, I already have a problem there because gender and ethnicity are showing up as variables that are useful to graph by. That worries me because this is a banking loan approval data set where I shouldn't have those kind of variables show us up as being important. We'll talk about that later. It's also telling me what combinations are important. So if you're drawing graphs in Tableau, for example, what this is telling you is if you draw a graph with the vertical axis being loan approved and the horizontal axis being things like tenure and balance and channel, these are useful graphs to draw. They're statistically sound. And these kind of combinations, like it might make sense for you to look at age and channel. So you might have one on the x-axis or horizontal axis, the other might be something you drill down into or filter into. Again, all of these combinations are going to turn out to have statistically sound signals in them. It also tells me that it has found several kinds of insights. We're going to go into this more when we get to explore, but this is telling me how important are individual variables and combinations of variables. So for example, it's found that credit score is really important, but the combination of credit score and products with bank is really important. Age is important, but not really by itself. Age is mostly important because of its interaction with channel and time of day. So you're getting a sense of which variables are more important and which are not. I still see ethnicity and gender show up here. I'm a little concerned about this. But in the meantime, the dataset that we started evaluating has completed, and you can see it looks identical to what we started with. So all I did is chose the outcome variable, and that's it. Everything else was automatic. Sometimes the data sets don't have such a nice data readiness score. Sometimes the data readiness score can be pretty low. And that is useful to know upfront before you spend a lot of time analyzing that data or creating predictive models on it. Sometimes the data readiness score is just a little too good to be true. This is a case where the data readiness is so high that the system is actually concerned that we might have what's called data leakage. And indeed, that's what it has flagged. This is a case where we are trying to predict whether the customer deal was won or not. And stage name is something that would also have that exact same information. And so it is so highly correlated that including this in a predictive model makes no sense. Similarly, if you were drawing some graphs, drawing a graph of is won by stage name would be a completely useless graph to draw. So Aible is looking at data quality in different ways. Is it good enough for a graph to be drawn, for a predictive model to be built? Is it too good to be true? And it helps you very quickly fix it. In this case, I would just apply and refresh analysis, and I would be done, and this data set would get updated. Second, let's say you have valuable data. How do you get to valuable insights? This is where you might be drawing some dashboards, you might be doing some visual analytics, you might be even training a predictive model. Aible has a capability called Aible Explore that automatically finds the key insights in the data and enables a collaborative open world exploration of the data. The focus here is how do we get analysts, business users, data scientists on the same page as quickly as possible so that the patterns in the data, the insights that the AI is going to rely on to make predictions, all of those things can be agreed upon as early as possible. Typically about 30 minutes after starting a project, we're already in an exploration working with customers. Now let's take a look at Aible Explore. I get to it just by clicking Explore Insights right here. And Aible is now automatically drawing some graphs for us to take a look at. It has considered all of the different variables that matter and combinations of variables that matter, and is drawing graphs and drill down graphs for me automatically. And it's telling me what are the most important variables, like credit score is really important, age is really important. Each of these chords is the combination of factors that affect a variable. So I might look at this and say, yeah, I know credit score is important, but what's going on with age? First thing first, if I click on age, what you'll notice is visually these graphs don't look that different, but middle age is slightly higher. But Aible is actually telling me that 70 of 83 predictive models thought that middle age has a negative impact on loan approval. And 48 of 83 models found that age young has a positive impact. This is exactly contradicted by what a visual BI approach would tell me. Well, let me take a look at this. What is happening here is there was a lot of different predictive models run. Some are neural net classifiers, some are GBMs. There's a Bayesian model in here somewhere. What happens, for example, in most augmented analytics products is at best they try one model. So if you had just used a Bayesian model, the Bayesian model would have said, hey, middle age is a slightly positive factor. But when you look at so many different models, you start getting a sense of how do different AIs consider that exact same factor. Is there a consensus among that AI? And in this case, I would say there's a broad consensus that middle age is a negative one. And there is a split decision when it comes to young people. Some are thinking it's a positive driver, some are thinking it's a negative driver. So we have to consider more than the obvious BI graph. We actually have to consider what is happening underneath it. And what happens underneath this is the software is looking at what else affects the behavior of age. So for example, what happens to age when the channel is direct mail? And we find that for senior citizens, direct mail is not working very well in this case, but for young people, it's working quite well. So some of the effect that you see for senior age is actually from the direct mail effort and had nothing to do with just age. Or age when time of day is morning. It turns out senior citizens are fantastic to reach out to in the morning. So if you are making lots of calls in the mornings, then it'll look like senior citizens are doing better than young people. It's just that young people are not very good to reach out to in the morning. So what Aible is doing is going beyond the basic BI and using AI to point out these underlying hidden patterns that better explain the actual BI pattern that you see. Think of it as it has done all the graphs, all the drill down graphs you could have possibly done, and it has evaluated those factors with 83 different predictive models, and now it's coming back to you with the combination of all that information telling you where you should be looking at, where you should go next. And notice these graphs are all related to a case where age behaves differently, but it's also telling me how to do a pivot the other way around, where the x-axis will be a different graph. So here it's showing you channel by for young people. So Aible is looking at all of these graphs and recommending where you should go. Notice ethnicity has shown up here, and this should worry me a little bit because the fact that ethnicity is considered important in a data set where we are trying to predict whether or not a bank should approve a loan worries me, because this means historically we must have had a pattern of loan approval decisions being affected by ethnicity. Interestingly enough, this is actually finding that 83 of 83 models are finding that ethnicity is white has a negative impact, Hispanic has a negative impact, and not specifying ethnicity has a positive impact. This is a kind of a strange situation, but this kind of patterns happen quite often. You might try to be so conscientious about not having an ethnic pattern that in the case of black people in this data set, most models think it has turned into a positive factor. For whites, it turned out to be negative. For Hispanics, it turned out to be negative. But the best situation is if you don't specify your ethnicity, those loans are getting approved at a preference. This is a case of an AI without any bias going in and finding the underlying pattern to the ethnicity issue. And we'll come back to this later when we get to optimize on how to deal with this ethnicity pattern. Any graph I'm looking at, I can just go ahead and pin this graph to my analysis. I can unpin it. Anything that I go in and add, I can download as a PowerPoint, and it will be auto-generated PowerPoint with all of the graphs and all of the notes right there. And one thing you should notice is that down below, we have a complete audit track where every chart I viewed, everything I did, did I drill into something, everything is logged in the system. And I can actually comment on these or assign these to a different user saying, hey, could you tell me figure out what is going on with this graph, for example? The key thing here is the collaboration of being able to bring in different users and working with them is built into the system. Finally, I can also search for any graph I want. So for example, draw a graph of email count. And this is a case where visually that graph might look interesting, but notice that Aible is telling me this is not an important factor. Other than the graphs that Aible does recommend to you, you can look at anything you want. You can also organize the information as you see fit, lay out the cards the way that it makes sense to you. And of course, with the Aible Tableau extension, all of the power of Sense and Explore is right inside Tableau. I choose a data set on my left, and I can see what does Sense think of it. I can see the data's readiness score, etc. If I actually go in and click on a graph on this dashboard, you'll see that Aible tells me how good this graph is, whether this is worth pursuing, what do the different model thinks of it, and it's recommending other graphs for me to take a look at. All of the power of Sense and Explore right inside Tableau dashboards today. Then going from valuable insights to optimal actions. Well, you might have a predictive model, for example, a model for predicting whether a customer will churn, but that doesn't get you to optimal actions because you have to consider what's the benefit of this customer? What's the cost of retaining the customer? Do we have a capacity constraint? If so, is this customer worth retaining? Once you go through all of that, you get to optimal actions, and Able Optimize helps you do exactly that. Unlike every other predictive solution or AutoML solution, we are not just trying to create a generic predictive model based on your data. We are actually understanding your business constraints, your business goals. What are you trying to achieve? What are your fairness objectives? And we combine all those business and fairness objectives and automatically create AI that conforms to it, that delivers the right optimal actions to achieve your strategy, to achieve your fairness objective. Let's start back from Sense. If you remember, we looked at the data readiness before, but now we'll look at these recommended derived fields where Able is suggesting maybe for that timestamp you might want to extract the trend or add a weekly pattern. I can also create some variables, but what I want to do here is predict whether a loan approved is yes. I do want to add a blueprint to this. A blueprint basically allows me to change the languages from records to predict, etc., to specific best practices and specific language for this use case, which is I want to predict which customer I should lend to. And more importantly, you'll see that this is going to be focused on fairness as well, because we noticed that ethnicity pattern previously. Let's go ahead and create our AI. Now we are in Aible Optimize. There's a few more models that will come in. But on the left-hand side, what you're seeing is what was this bank doing before in a baseline period. So maybe that's a quarter, maybe that's a year. But what you can see is they had looked at a lot of loan prospects. They had reviewed many of the applications, and unfortunately, they got a very low funding rate. This had actually happened because many of the applicants were unable to get the property. So this bank is trying to figure out which applicants should I focus on if I'm concerned about whether I'll be able to fund the loan. And that's a very different question. Now notice initially Able is going for a pretty conservative strategy here, but in fact it is telling me to stop reviewing 3/4 of my loans because so few of the loans are getting funded. This is what an AI might do if it was going for a very conservative, accuracy-oriented perspective. But as a business owner, I know that's not what I want to do. I don't want to stop reviewing 2/3 of the loans. So I'm going to go in and change my business strategy here. For example, what if I continued looking at the exact same number of applications as before? How could I do better? And now it's saying, yeah, of course, if you want to continue reviewing the same number of applications, I can do that. Your lending revenue is going to be even better, much better, in fact, but you're still going to be unprofitable, even though your profitability will increase. Now, I might want to go for a more balanced strategy. So for example, I might want to grow my revenue by 50%. And this then tells me, yes, I can do that too. All that would happen is you'd be reviewing about half of your applications. Your lending revenue will go up by 1.9 and your profit will go up by 6.3. And you're going to be profitable in the end while getting a nice revenue. Now, every time I was changing these scenarios, the underlying models were actually changing. So here, this is an LGBM that has been picked, and there is a certain amount of money that was paid to train this. Let me just pin this here. As I go in and change the strategies as I was doing before, from lending revenue 150% back to net profit, or changing it to review effort, you see that the underlying model drivers are changing because the model this is choosing is different in the situation. Rather than thinking in the language of models, we are talking about the language of business strategy and saying how that would affect our business instead of talking data science. And of course, we can talk data science if we want. We might also want to take a look at the fairness goals here. So right now, there are no equality constraints in this business as we have set it up. I might go in and say, well, I want the rejection rate to be equal. I basically, across ethnicities, I want to make sure my rejection rate is the same. And it says, I can do that. I can get you down to where the difference between the rejection rates is only 0.69%. And your net profit is going to go down a little bit. Your lending revenue will go down a little bit. Let me go back to no equality constraint. You'll see that lending revenue was 7 mil. The profit was minus 1.8. In this case, your revenue doesn't change that much, but your profitability definitely goes down quite a bit. Now, this is a trade-off I might be willing to take, or I might say, you know what, I'm actually okay with the max difference being around 5%, and then the system comes in and says, okay, then I can get your profitability down to 1.8, so I can make it much better. I can also choose a different metric altogether, like let's have the funded rate, loan approval rate be identical. What is the economic impact of that? What you're seeing happen here is I am setting a business goal, which was in this case review effort of at least 100%. I'm setting a fairness goal, and Aible is dialing in the AI to deliver what we want as our business strategy. And once I'm done, all I have to do is just say I want to deploy the AI, and that's it. This will actually get deployed into my own cloud account. All of the data cleansing code, data transformation code automatically gets applied. All of the routing rules automatically gets applied, and the whole project gets completed. And I can also give the end users the ability to make small adjustments to the model to their unique preferences or not. And this can now be integrated into Salesforce, Tableau, whatever you want. But we went from raw data to model training to making sure the model aligned with our business strategy to making sure the model also aligned with our fairness strategy, and then deployed it live into the customer's own cloud server, all in a matter of minutes. And finally, of course, you have to consider whether the end users will adopt the technology, because if they don't, it's completely wasted. Now, Aible actually enables you to customize the AI for individuals. So think of a sales optimization use case. I might have a salesperson who likes to crank through a lot of deals very quickly. I may have a salesperson who likes fewer, better deals that they can focus on. Well, how can one AI serve both of them? Aible allows the end users to quickly and simply adjust the AI to their preferences, and it then monitors the user adoption. Are they following the recommendations of the AI? When are they following? When are they not? What is the implication of that? Are we delivering business value? And not only does it monitor that, it also observes shifts in the market. So it'll come back and tell you, hey, your deal flow is going down, so you might want to switch to a different AI because the future doesn't look like what you expected it to be. So change management in the sense of the market conditions changing, external factors changing, and change management in the context of helping your end users actually adopt the technology so you get business impact from it. Now, you saw a demo in the context of a bank loan approval use case. That is just one of the many use cases. Aible has this thing called a blueprint that dials the product into the specific best practices, the specific language of that use case. We have dozens of them, and you can go to this website to go take a look at these blueprints, use case by use case, industry by industry, business function by business functions. These are some of our top functions, such as banking and insurance, looking at things like loan applications, policy churn. We have done stuff around claim fraud. Of course, we have done stuff around promotional offers. But our key focus from a horizontal perspective remains things like sales and marketing, operations, and customer success. Now, we talked about how all of this analysis was done on serverless. Now, with Intel, we have been doing this benchmark program, and please do go take a look at this URL to get all the details. What we did is we took the same workload, same predictive model, same data, and we ran it on servers and ran it on serverless. The cost per job on serverless was actually 2 to 3 times better. If you look at it from a total cost of ownership, the difference was even better, 3 to 4 times better, because in the case of cost per job, we were not considering things like cost of the server that was running all the time or control plane and things of that nature. And finally, speed of getting to results. So this is the actual elapsed time from when you start running the predictive model training to when you get all the models to complete. That was much better on serverless. In fact, what is even more important is the first predictive model would come back in a matter of minutes, and that actually allows you to quickly figure out whether you have made a mistake and fix it rather than waiting for a whole long server training load to run. Please take part in the Intel benchmark if you want to learn more about this. We still might have a couple of spots, but either way, you should take part in this. And if you're too late for the program, try out the exact same thing. See how you can get to value in 30 days. See what your serverless costs are compared to your server training costs for AI. Thank you again for your time. Please take a look at this website to learn more.